And we're going to take a look now at some of our different Fractal Node options. So I just want to delete all of the filters and everything else we were using before, so that we're just left with our Fractal Node. And just move down our position so that we can see this a little bit better once we zoom in. And we're going to select our fractal, which we can see showing up right now. Now, this is currently a simple fractal. Within our simple fractal, we have our filter. And I'm just going to go ahead and create a small filter for this right now. Add a couple of key points, and we can modify it. And we can see the effect showing up of this direct filter within our fractal. We have a couple of different amounts. We have our creep in, min, and then max. If we decrease our maximum, we can see that effect. And if we take a look at our preview in the black and white, we can really see that a lot better of what actually is happening. Decrease that quite a bit, it's going to disappear completely from our preview, although we can still see the overall terrain. If I turn off fit vertically, we're going to see that we really don't have much to work with. So we'll increase our max. Now we can just see those lower levels, and it's still using our filter directly. And then we can adjust the minimum amount. And basically this is just moving through our filter, the maximum amount of our filter and the minimum amount. And then we increase that minimum. You can see that lowers or increases our lower amounts. And then we also have the creep in. We increase that value. Then we can see we get a lot more detail. Pull that out, and things are a little more smooth to that filter. So those are some of the options available for just our basic simple fractal. We can also adjust our noise, and we can see we have all of these different options. And we've gone through a lot of them already, but we can really get some very neat looking terrains just by using some of these different patterns by themselves. We'll go to the Voronoi, and we can see what that looks like. Now right now this is quite large, or basically our wavelength is a little too small, so we're seeing lots of details. So I'm going to increase our wavelength up to 1 on each of our axes. And that way we can see the overall effect of what this terrain looks like. And the Voronoi Tessellation can create some very interesting looking terrains. And now we still have that filter on too, so I'm going to go ahead and just reset that filter. And we can also see that our creep in, min, max values are now grayed out. So if we take a look now without the filter, we can see the terrain a little bit better. And we can move our scale if we want to zoom out a little bit more and really see the full amount of this pattern. We also have a couple of different options for this. If we take a look, we have an altitude based. You can see that, and we also have a generalized. And generalized will typically take the longest to process and render out, so sometimes it might not be needed. But really the best way to tell the difference between those ones is just to create a noise node and make sure we don't connect it to anything. Select our cellular patterns, and now we can take a look at each of these individual options. I'm going to increase our scale just so we can see this a little bit better. And now we can either take a look at the actual noise node itself in our preview to see what that looks like. And I'll just scale that up. So this is our basic Varonoi. And we can see our altitude. And the differences are basically our altitude variations and also that we have a lot of gaps in between, plus it's not so patterned. And then we can also take a look at the generalized, which is kind of a combination of both of them. And of course, if we're using a fractal, we're going to see a lot more detail, but using the noise will allow us to take a look at this first before we really move to a fractal to see if it's what we want. And it can sometimes be a lot quicker to do so because it does take a lot longer to process and render that fractal node as opposed to the noise node. Now, a lot of our different options in here really aren't going to work very well for terrains. If we change this to Pebble Noise, we can see this works pretty well. Of course, we have our noise node selection, so we want to switch over to our fractal, and we're going to change that to our Pebble Noise. And we can see that show up, and we get a pretty interesting looking terrain. But the main thing is we have a lot of these square features, and that can be somewhat distracting. If we go back in there, take a look at crystals, and see what kind of an effect that creates, you can see we get a pretty nice looking terrain, but still we sort of have those sort of square looks. We can go to chipped, and overall that looks pretty good. Let's take a look at some of the ones that really don't work that well. If we go to flat patterns, do varying blocks, we can see when that shows up, although we do get a very interesting looking terrain, if that's what you're going for, then you can definitely use it. But for creating something a little more realistic, and that blends a little bit nicer, this really isn't a type of node that you want to be using for creating specific terrains. We can go back into the flat patterns, take a look at clumps, and we can see that same sort of an effect, where it's a very tessellated mess, and it doesn't really work well for a terrain. Take a look at some of our math patterns. If we take a look at spiral, we can see that that's really not something we want to be using to create a terrain. We can take a look at the onion and see the same sort of an effect. Some of these we really don't want to use as our main production for our terrain, but rather a way to control certain aspects of our terrain. We can go to the square patterns, take a look at squares, and we can see when that shows up, we get lots of little pyramids. But overall, it's something that really wouldn't work very well for a terrain. And there's a lot of options that are like that, and really the best way to is just to go through and see which ones look best and which ones will work. Because of course with this one, it's really not something we'd want to be using. Go back to our math patterns, we do water wave. And we can see this one might work, but the main problem is we can still see a lot of those patterns in there. So it's really something you might want to be using for more of materials and controlling your surface rather than actually the main terrain. If we go to cracks, see that show up, really not something you'd want to be using once again. And a lot of these you just want to basically use as a noise to sort of combine with a fractal in order to create those sort of effects. Because really, overall, if we take a look, there's a little bit too much detail. And even if I decrease our roughness, we can take a look. We still have a lot of gaps in between things. If I turn off fit vertically, we'll see a little bit of a flatter pattern. But this still isn't something you'd want to be as your base for your terrain. So I'm going to increase our roughness, and let's just change this to something else. Go to Purlin noises, we can select value. You can see that show up. Not a very good representation right now because of our size of our wavelength. So we'll change this, and let's do a 0.4 on each of our axes, so we can see that a little bit better. I'm going to turn fit vertically on, and now we can see that terrain a little bit better. And this one works very well for creating terrains. We can go back in there, and we can see that we also have gradient, which is very similar. And to the right of all of these, we see an edit option. If we go ahead and click on edit, this gives us a couple of new options. We can give it a title, also add a description, which we also have for basically all of our nodes. And if we were to type in titles and descriptions, we would see those show up within our graph. But we also have a couple of other options. We can select animated. And once we do that, it'll automatically make this connection that we can see in our graph editor to time. And that way we can create some very interesting looking animated terrains. And we can also turn on rigid, which will give you different effects depending on which type of pattern you have selected. Just going to exit out of that. And if you note, when I hit X, it still left our values on there, basically because it is real time. So we'll just keep that open, and I'm also going to disconnect our time. And we can see our time is still showing up on the top. Go to Edit, turn off Animated, and click OK. And now we no longer have that option available. But that basically applies to most of our different patterns. Changes to Cellular Patterns Drought, click Edit. And now in this case, we don't have the ability to animate it, but we do have other options. We can adjust our crack width. Make that smaller or larger. And each one of these settings is going to be a little bit different depending on what it is you have selected. We can go to Voronoi, Edit, and now we have a couple of different options. We have a neighbor mode, and then we also have a Voronoi profile. With the Voronoi, we have a neighbor mode, which allows us to select a variety of different options. And the best way to really see these is to just use a noise node and change through them. And that way, you'll be able to tell a little bit differently what each of those options will do. If we go to the profile, we can also adjust the overall shape. We can set it to flat. We can set spikes, angles, rounded, and also smooth rounded. And right now we really don't see a whole lot of a change in our output. Just going to click OK. So let's switch over to that noise node. I'm going to change that to our Varonoi. And now we can see we have the neighbor mode and the profile. So let's connect our altitude to our noise so that we can see this. And we'll go through each of our neighbor modes. We can see with second closest neighbor on, we end up with an entirely different type of an effect. A lot harsher edges in certain areas. And we have a lot of flattening between different objects. Go to the third closest neighbor, the same sort of an effect, except we have some smaller areas. Do the fourth closest, and we see a little bit more variation. First and second, we have more of a tessellation that we can see, and something a little more similar to the cracks. Move to second to third, basically the same thing, a little more variation. And third to fourth, pretty much the same as the previous. We'll go back to our closest neighbor, which works pretty much the best for our terrains. And we can take a look at the profile. Right now it's set to round. If we select flat, now we can see that we have these different steps. If we change this to spikes, we can see instead of these rounded humps that we had before, we have some spiky areas, which can give us some really neat looking terrains. We can go to angles. It's a little bit different. Back to rounded, and then also smooth rounded, which is going to give us more of a plateau on the top rather than a hump. It's something just a little more smooth and flat. So this is definitely a very versatile pattern that we have available, and using the noise node and connecting to our altitude is just a fantastic way to really see what's available. So let's go ahead and connect this back to our fractal. And if we take a look at some of our features, we have our largest feature. We can increase, and that way our largest feature, in other words, the largest part of our fractal, is going to be at least the value we have entered, which is currently 74, which in this case is quite large. If we reduce that down to 12, then our highest point is going to be 12. Reduce that down even smaller, then we can see we have much more humps in between and a lot more overall varied areas because our largest feature is very small. We can make that even smaller, and now we noticed a very rough looking terrain. So we'll just go ahead and increase that so that we have some larger areas. The same thing with the smallest feature. Currently is set to 0, but I can make that a little bit larger, so then our smallest features are at least a specific size. We'll go ahead and set that back down to around 0, or we can just type in the value of 0. And then we have our roughness, where we can adjust just the overall erraticness of our shape. We can also see a very good preview of that within our node. And then our gain as well, where we can adjust the overall contrast. And in this case, we're really not going to see a whole lot of a change with our gain option. If I turn off fit vertically, we might see that a little bit better. We reduce that. We can see it becomes a lot flatter at the lower values. If we reduce that or increase that to a very high amount, then we can see a very harsh contrast and a much more shapely terrain. I'll change that back to fit vertically. And let's take a look at some of our other types of fractal nodes. This whole time we've been working with simple fractals. What we also have is a basic repeater. Basic repeater is a much more smooth surface, as we can see. We also have a lot of different options for editing this. Mainly we have our harmonic behavior, but we also have our filtering like we did before. If we take a look, we see that we no longer have our largest and smallest features and roughness and gain, but we have just a wavelength and an origin. But we can also go in here and edit to select if we want this rigid or animated, depending on whatever noise we have set. We're still on the Purlin noise gradient. But we can take a look, harmonic behavior. We can see we have a repeat function. And if we bring that down, then we can take a look at our different values. In this case, we really don't see a whole lot of a change with this specific node. But we can adjust our scale and pull that down. Now we can see much smaller amounts, and we're starting to get a little more detail in our node. And then we also have the amplitude, which is basically the equivalent to our roughness. Increase our scale, increase our amplitude, and we can see that we have more of a contrast setting. At the smaller numbers, it does reflect our roughness, but if we take a look at the fractal in the actual node in the preview, we can see we just have an overall brightness and contrast setting. And you can just make that up to a very high value, or something a little bit smaller for something a little bit smoother. And each of these settings can also be connected to other nodes. If we take a look to the right, you can see we majorly have our wavelength, showing up for our node. If we want to extract any of these different parameters, we can go ahead and do that just by clicking on the Extract Parameter button. We also have our filtering on the bottom. We can adjust our minimum and maximum, and then also create a specific filter. We'll just go ahead and create something really quick. And now we can see that showing up where we have our divots sort of at the top. Just go ahead and exit out of that. If we go back to our harmonic behavior, we can see we have a couple of different modes for our combination. Currently it's set to add, which is the default. We could also set that to blend. We do a variable roughness. We have 2 variable roughness, and then we also have max. We can see all these show up, minimum, and they'll each give us different types of effects. I'm just going to set that back to add, which is the default. And basically our basic repeater is something a little more similar to our noise nodes, just because we don't have all of those extra details that we normally get when we're working with some of the other different types of fractals. So let's move on, take a look at some of our other settings. Our next would be the simple fractal, which we already took a look at. So let's take a look at the fast Purlin fractal. And with our fast Purlin fractal, it's in a very quick processing terrain. We also have our largest feature, smallest feature, roughness, and gain, as we did with our, take a look, our simple fractal. We can also adjust our wavelength, but overall, we really can't adjust the overall shape. We don't have any specific patterns to choose from, because it's just a Purlin fractal. But of course we can use our other settings to adjust exactly how this looks, so we don't necessarily have to stick with exactly just this basic look. We can always add turbulence nodes to it. Or once we get into the combiners, you can see how we can also combine these with our other nodes. So let's just go ahead really quick and make a modification to this so we can see that we can really expand upon these fast Purlin fractals, and they're not extremely limiting. I'm going to extract our origin, convert that to a turbulence node, and then I'm going to adjust this to Voronoi, and now we can see that showing up where we have a very interesting looking terrain, and we can use any of these different options like we were doing before. We can switch that to sawteeth, and we can vary that up, get some nice twists and turns in there. Set that to even spiral. Let that process. And we can see that we have more of a square-shaped terrain in this case. But we can easily modify these turbulence nodes plugged in just as we did before, using our fast Purlin fractal to control a little bit more. Change that to chipped. And now we can see we end up with a very fast processing terrain where we don't really have a lot of editing options, but by using other nodes to control it, we can get very quickly rendering terrains and something that processes a little bit faster. So I'll just delete our turbulence node, also delete our connection. We'll go back to our fast Purlin fractal, and we're going to move on. Next is our variable roughness fractal, which has all of the same settings as our simple fractal that we were using before, but now we also have a variable roughness section. This gives us a smooth level, influence, local influence, and a creep-in amount. So let's go ahead and change this. We're using a Purlin noise gradient. Let's change this to Purlin noise value. And I'm going to decrease our wavelength to about 0.4 on all of our axes. And we can see what our terrain looks like right now. If we take a look at the variable roughness, you can see we can adjust our smoothing level. And if we just take a look at how this is processing, bring this down a little bit lower, we do see we have a nice variance. With the smoothing level, we can see we have very smooth areas on the bottom, And on the top, we still have a lot of our roughness. We can adjust the influence, increase our smoothing, or decrease it. And really, by paying attention to your gradient in your black and white image, you can see a little bit better what's going on. We can adjust our local influence, and also the creep-in amount. You can see now we end up with an extremely rough-looking terrain, and we don't see as much of the variation. So it's something that's very useful if we want to create something a little more varied. We'll adjust our creep in. Now we can see more of that smoothing on the bottom. If we increase our local influence, we see a lot more roughness towards the bottom. Decrease that down to 0. Adjust our main influence up a little. Adjust our smoothing level. And we can just see all the different variations that we can create. So these are very useful for creating effects different from some of your other nodes and some of your simple fractals, where we can create a little bit of variance overall throughout the surface. And like I said, we can do this with any of the other options as well. We can change this to Voronoi. We can see that show up. And I'm just going to increase our wavelength for this one up to 1 for all of our axes. And we'll let that process. And now we can adjust the smooth level and see that process. And now we can see we have much more smoothing in some of our lower areas. Increase that a little bit more. And now overall, we can see our bumps are a little closer together. We have a lot less of a harsh cutoff and a lot less cliffs and divots. We decrease our influence, and now we can see those holes start to come back. And then we can always adjust the creep-in amount as well. And we can see a little bit more roughness in there. Plus, we could always end up adding a filter to this, just as we did before. Just turn on curves, and I'm just going to create a new key point and make a very simple filter. Click OK, and now we can see a really interesting looking terrain and a nice looking landscape. Okay, so let's move on. Our next is a variable noise fractal. And in this case, what I'll need to do is shrink down our function editor just a little so that we can expand that bottom and really see all of our different options. Now this one's also very similar to the previous two we were looking at, or our variable roughness and our simple, except now we have the option to have variable noises. What this gives us the ability to do is to use two different nodes in two different patterns within the exact same fractal node, and that way we don't have to make any specific connections. We also still have our editabilities for each of our noise nodes, or each of our patterns in our pattern noise. We can also turn on rotation, and then if you notice underneath, we also have a lot of different options. So let's just take a look and change this around a little. I'm going to change from our cellular patterns to chipped. We can see that show up. Now we also have this mixed with our Purlin noise gradient. Well, let's mix this with something that's going to be a little more obvious. And let's just mix that with cracks. And now we can see those cracks showing up in those different areas. And they're both blending together. If we go to our wavelength, I want to make this just a little bit smaller. I'm going to do 0.5. And now we can see a little bit more. But overall, we just have this really nice cracks showing up, which are showing up as elevations, mixed together with our chipped pattern. And then we have our switch level, which will allow us to switch in between whichever noise we would like to be the dominant noise. If I increase that even higher, you can see we're more towards our chipped once we're at the higher values, and once we bring it down lower, we're more towards our noise 2, which is our cracks. And if we bring that down to 0, then we have equal influence throughout both of the noises. We also have a switch speed, and we can reduce that. And now we see a lot less of the detail from our cracks that we had, but also more of the cracking pattern within our chipped noise. So we can adjust those values. And also too, just make sure you're paying attention to the gradient so we can really see what's happening to our surface, rather than only paying attention to the output, because sometimes it could be a little difficult to tell. But we can just see how we're adjusting mainly the opacity between these different textures. We can also adjust these switch levels based on different parameters. So we could control this with another node if we wanted to create a rather interesting looking terrain. We also have our local influence, which in this case is increasing our crack amount, or our noise 2, at our higher levels. And we can see all of that definition in there. We can decrease that value, and now we're not seeing as much definition from that noise 2. And we could change this to something else. We can select our math. Let's do a sine wave. Now we can see those humps showing up. We'll change this to gradient. And now we can see those two combined. We change our switch level. We could switch in between the dominant noise, and then also our switch speed, which in this case we're really not seeing too much of a change. And then also our local influence, which we can see is, in this case, is sharpening the tips of our objects. If we decrease that, then we have more rounded tips. But it really depends on which noise you're using to edit, really which effects you're going to get out of these different options. And if we move on, we'll change this to a 3-noise fractal, which I'll also need to adjust the function editor and size it down a little bit more so we can see all of the different options. I'm also going to decrease the size of our output observer just so we can see all of the new options we have available. The 3-noise fractal is a combination of almost all of the different fractals together. What we end up with is, if we take a look, we have our large scale noise, which currently is set to our sine wave, which we had before. I'm going to change this to, let's go to Purlin noises gradient. I'm also going to go ahead and decrease the wavelength. And that is our base setting. We can also adjust the largest and smallest feature and our roughness, just as we would with any other setting. If we move over to the right really quick, we can see we also have our mid-scale noise and our small-scale noise. So let's adjust our mid-scale noise. We're going to go to Math Patterns, and I'm going to select Onion, just so we can really see what's showing up. And if we take a look, we can see that onion pattern in that area. I'm going to go ahead and change this to something a little more realistic. We'll use Varonoi. And now we can see that showing up for our mid-scale. We also have a changeover scale, which allows us to adjust the overall scale of this mid-scale noise. You can see we can make it very large. And once we get to the higher values, we start to overwrite pretty much what we have for our large-scale noise. But our large-scale noise is really defining just the overall shape. And then we can use our mid-scale and small-scale to modify those values. So we can see we now have those tiny little bumps from the Voronoi showing up throughout our terrain for our mid-scale noise. I'm going to change that to flat patterns clumps. And now we can see those clumps showing up. Reduce our scale, or we can increase it and see what happens. So we get a very, very rough shape in that case. Turn that down. And then we also have our small scale noise. So I'm going to change this to math patterns leopard. And we really can't see that showing up. So I'll change that to, let's just change that to onion. And now we can just barely make out those rings showing up. But it's our very, very small scale noise. So I'm going to change this to cellular patterns. Use chipped. And then we can either increase that scale so we can see it a little bit larger. Of course, that's going to smooth it out because it is our smallest scale noise, which is going to give us the most amount of detail. So we want to make sure that this is at a proper value. If we go back over to the left, we can see we also have variable roughness. So we can adjust the smoothing level. And now we can see a nice variance between our different smoothed areas. We have the roughness variability. You can see the effects that that is creating. Where now we have a lot more variation. And we can adjust how varied that is with that setting. We also have our creep in amount and local influence, just like we did before. We also have our turbulence dampening, which allows us to adjust the overall blend between our mid-scale, small-scale, and large-scale noise. Now with this current setting, we're really not going to see an overall effect. Basically, if we were working with something where we'd be able to see our entire fractal a little bit better in the preview, we'd see it a little bit better. Basically, it just blends together our different options and how much turbulence or the origin is affecting all of our different options. And once again, we can also adjust these with other nodes. So I could control our origin with some turbulence. And we could see that showing up. Maybe let's change that to something a little bit larger. And we can see the effect a little bit better. You can see we end up with a very interesting looking terrain, lots of detail, and it looks very cool. So let's take a look at our last option. I'm going to delete our turbulence node that we just added, also our connector. Go back to our 3-noise fractal and change it to Open Ocean. Open Ocean is a really cool fractal node which allows us to simulate ocean waves by using a procedural terrain. As you can see, the connection is automatically connected to our time, and we can adjust all of our different options, our wind direction, so we can change exactly where our waves are being created. Also the intensity, our largest feature and smallest feature, wavelength, origin, and then under waves, we have a lot of different options for adjusting the overall shapes of our waves. Now keep in mind, we have this set to fit vertically right now, so it's going to show up a lot higher. But if we turn that off, we can see a lot better representation of our overall look of our waves. And of course, what you'll want to do is just adjust the up and down axis, and basically the Z, for the shape of your terrain in order to get it to look correct so that you can actually use this as a way of creating waves. To just create a very realistic looking ocean. And like I said, we can just adjust the overall wave size. We could do the largest feature and the smallest feature. And then basically you just want to make sure that it's covering the entire area that's going to be water. And that way you can end up creating some very nice looking ocean waves. And all you really need to do is apply a liquid surface to it, or one of the preset water surfaces, or set up your own. And then you can get a proper looking ocean wave by using a fractal node.